Hey guys, we are back here with the same continuation of the topic, and that was related to atomic structure and basic information related to elements, compounds, and mixture. Afterwards, I was just telling you that there are two types of the compounds: ionic compounds and covalent compounds, and a brief introduction to periodic table as well, that where are the metals, where are the non-metals, etc. Now I am on this page, which is just telling you that what is the atomic number, what is the mass number, and what is the symbol of an element. Okay, so this was the information from the periodic table. That's why we can say a periodic table is a symbolic representation of elements. Okay, now I'm on the next page, and that is related to, you may consider a term that is called a mixture. Okay, now what is a mixture? It's a physical combination in which there is no reaction, no chemical reaction, or you may say no chemical change. No chemical, basically a chemical reaction and a chemical change are the same things. So in this mixture formation there is no chemical reaction and no chemical change associated. So mixture is a physical combination of what two or three types of mixtures we may consider them. Generically, we can say there are three types of the mixture. So number one is the element mixture, in which elements and elements are combining together. For example, you may consider air for this. We know oxygen and nitrogen are the elements, the gases which are combining with each other. I mean to say, which are mixed up with each other in the air. So this is one of the example. There are other gases as well in air. I'm going to tell you the composition of air on the next page. And then there is a second type, and that is the element and compound. Okay, element on plus compound mixture. Okay, in the element plus compound mixture, there can be a mixture of elements and compounds. For example, you then again consider air. In air, basically carbon dioxide is present. In air, water vapors are present too, along with nitrogen, oxygen, argon gas, for example. So compound is carbon dioxide and water, whereas nitrogen, oxygen, and argon are the examples of different elements. Okay, then there can be a third type, and that is a compound and compound. Here, compound plus compound mixture. In case of compound and compound, where the different types of the compounds are there, but they are not reacting with each other. So, for example, we can say in air we are having carbon dioxide and H2O, whereas in case of sea water, for example, you can see water is there and SiO2. What is SiO2? It is the formula for sand. Sand is part of seawater. Along with these, there is a major component, and that is called NaCl. For example, there are different other dissolved salts as well, but we can mention NaCl. A taste of seawater is salted. Many of you have experienced that, and that is telling you that all these are part of sea. So we can say compounds and compounds can be mixed up with each other in case of sea water. Okay, so here I am telling you how we can differentiate between a and compound and mixture. What is the difference between compound and mixture? Okay, so there can be three types of the differences between a compound and a mixture. Number one is this, that in case of a compound, there is a fixed ratio of the components. Components are not combining randomly. In case of a compound, they are combining in a fixed ratio, whereas we can say fixed ratio. Okay, but in case of a mixture, there is no fixed ratio. In case of a mixture, there is no fixed ratio. So we can say this thing that in case of a compound, always, for example, NaCl, we can say this is the formula. It is just telling you one Na and one Cl are combining with each other always. For example, in the formula of H2O, two hydrogen atoms are combining with one oxygen always, but in case of a mixture, no ratio, they can be combined in any ratio. Okay, so number two is this, that in case of a compound, the properties of the components are altogether change from their original properties. For example, we can say that sodium is a metal at room temperature and it is of silver gray color, okay, and it can catch fire when it is in contact with water, okay. But we are saying that when it is part of sodium chloride, we are dissolving it in our food daily, but nothing is happening, and there is no silver gray color associated with sodium chloride. So here we can say that properties are changed. I am telling you about chlorine now. Chlorine is used as a disinfectant. Many of you have experience in the swimming pools. The smell of the chlorine is there. It is used as a disinfectant, and chlorine is used as a bleaching agent as well. But both of these properties are not observed in the case of sodium chloride, where it is used as a major component of our food. Okay. So when we are talking about a mixture, the properties of the components remain same. For example, just consider the mixture of sand and sodium chloride, and sand and sodium chloride remain in the form of sand and sodium chloride. We can even differentiate among the particles of sand and sodium chloride, which one is white in color, that is the sodium chloride, and the grayish silver thingy is the sand. So we can say this thing that they are maintaining their properties in case of a mixture. If we are, so what will be the point number two? Prop Maintenance of the properties. Maintaining the properties in mixture, but lost properties in compound. Not maintaining the, okay, properties in compound. They are losing their properties while making a compound. When now we are discussing point number three, that is the third difference between a compound and a mixture. We can say this thing that in a compound and a mixture, we cannot segregate. We cannot go back to the component's original state in case of a compound by physical methods. We can go to the original state of the components by electrolysis. Electrolysis. Now, what is electrolysis? It is basically the passage of electric current through a substance, and the substance convert itself into its components. Okay. So basically, I will teach you the electrolysis. I will tell you the better definition of electrolysis, which is okay. I can share it right now with you. Electrolysis is basically passage of electric current through an ionic compound, either through its solution form or through its molten state. Okay, and then the ionic compound breaks up into its component to its original form. So for example, if we are going to pass electricity through sodium chloride solution or through sodium chloride molten state, it will convert itself back to the sodium metal and chlorine gas. But if we are passing it through other different physical methods like dissolving in water or etc., etc., filtration, they are not going to segregate the components of a compound. But in case of a mixture, the physical methods can be used to segregate the components. So in case of a mixture, the separation is possible, but in case of a compound, the separation is not possible. All right, guys. So this lecture was related to mixture and the differences between mixture and the compound. In the next lecture, inshallah, I'm going to share with you is related to metal and alloy, general structure of a metal and general structure of an alloy, inshallah. Take care of yourself. See you in the next class. Thank you very much.